All right, today we are going to be talking about graphs of rational functions. And when we have a rational function, it basically means that we have a fraction. And when you have a fraction with variables on the bottom, you generally end up with these boomerang looking things. Now, sometimes weird things happen in the middle, but generally when you end up with what we call the reciprocal function, which is when the mother function of all reciprocals is just 1 over plain old x. And you get these two boomerang looking things, okay? Your domain, there's obviously a jump there because the denominator can never equal 0. So your domain goes from negative infinity to 0 and then 0 to infinity. There's also a horizontal asymptote here. So there's a break in the graph. So your range goes from negative infinity to 0 and then 0 to infinity. It's continuous on all x not equal to 0. It's decreasing from negative infinity to 0 because as I go from negative infinity to 0, the function is going down. And from 0 to infinity, it's also decreasing because if I trace it, it's going down. It's symmetric with respect to the origin. It's an odd function because you can tell it reflects diagonally. It's unbounded. There's no local extrema. Your horizontal asymptote is y equals 0, like I talked about, and the vertical asymptote is x equals 0. And so when we describe the end behavior, we say the limit as x approaches negative infinity, the function is getting closer and closer to this horizontal line. So we say the function is approaching 0. Same way with this. As x approaches positive infinity, the function is getting closer and closer to y equals 0. Okay, so to figure out what our asymptotes are, your end behavior asymptote, which is also the horizontal asymptote, you get by your degree rules. If the top degree, okay, when they're talking about n and m, they're talking about the degree of the top function, and m is talking about the degree of the denominator. If the top degree is smaller than the bottom degree, then your horizontal asymptote will be at y equals 0. If the top degree is equivalent to the bottom degree, then your asymptote will be the quotient of the top leading coefficient divided by the bottom leading coefficient. If the bottom degree is bigger than the top degree is bigger than the bottom degree, then you won't have a horizontal asymptote, but you will have what we call a slant asymptote. And you get it by dividing. Your slant asymptote will be the quotient when you divide the two functions. Your vertical asymptotes, those are when Mr. Denominator equals 0. Your X-Intercepts, to figure out where it crosses the x-axis, all you do is solve the numerator. Just set the numerator equal to 0 and solve it. Those will be where it crosses the X-Intercept, or the x-axis. And to get your Y-Intercept, you plug in 0 for x and solve. So, some transformations, okay? Reflections, if it's a positive, it's going to curve in quadrants 3 and 1. So it'll be here and here. If it's negative, then it's going to curve in quadrants 2 and 4. Okay, it's going to shift right or left if you look at the denominator. If you're adding or subtracting something from x on the bottom, then it's going to shift it right or left. If you're adding or subtracting something on the outside of the fraction, that's going to shift it up or down. And then your stretching is whatever's on top. Now, if the top has a variable, to figure out your stretch, you're going to have to do long division. And basically, your quotient is going to be the vertical stretch. The vertical shift, sorry. And the remainder is going to be your vertical stretch. Okay? Again, your horizontal asymptotes, you use your degree rules. If the top degree is smaller than the bottom degree, then your horizontal asymptote's at y equals 0. If the top degree equals the bottom degree, then your horizontal asymptote is the quotient. You divide the top leading coefficient by the bottom. And if the top degree is bigger than the bottom degree, there's no horizontal asymptote, but there will be a slant one at the quotient. Your vertical asymptotes, Mr. Denominator can never equal 0. Your X-Intercept, set the numerator equal to 0 and solve it. And to get your Y-Intercept, you substitute 0 for all the x's and solve. So it says, describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function f of x equals 1 over x. Identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior, and then sketch a graph of the function. Alright, so here's what we do. First of all, would you agree that I could rewrite this as 2 times 1 over x plus 3? Okay, you take whatever's on the numerator, put it outside, and change that to a 1. Only if it's a constant. Not if there's a variable up there, you can't do anything about that. But if it's just a constant up there, you can always pull it to the side and say that's times. And that's why you can see the multiplication is a stretch. Okay, so the positive 3 is going to make it shift 3 units left. The multiply by 2 is going to be a vertical because it's outside, and it's going to be a stretch because it's bigger than 1. Okay, so we've got our description. Now we have to find the horizontal and vertical asymptotes. To find my vertical asymptotes, you say, Mr. Denominator, you can never equal 0. Minus 3, x can never equal negative 3. So at negative 3, there's going to be a vertical asymptote. There's going to be a jump in my graph there. Okay? There's my vertical asymptote. My horizontal asymptote, you do the degree rules. My top degree is 0 because there's no x. My bottom degree is 1 because it's x to the first plus 3. So my top degree is smaller than my bottom degree. If my top degree is smaller than my bottom degree, then my horizontal asymptote is at y equals 0. There's 0 on the y-axis. Horizontal means draw a horizontal line through it. So there's my horizontal asymptote. Okay, so now what they want us to do is pick several ordered pairs around your asymptotes. So what I would do if I was totally doing this by hand is I would maybe plug in negative 2, we could get, the X-Intercepts and the Y-Intercepts. To get the X-Intercepts, you set the numerator equal to 0. Well, if I set the numerator equal to 0, that's just silly. There's no x in it. So there are no X-Intercepts. This thing won't cross the x-axis. To get my Y-Intercept, I find f of 0, in this case g of 0, which would be 2 over 0 plus 3, which would be 2/3. So this thing is going to pass through 0, 2/3, about right there. Okay, so now obviously 1 point is not enough to figure out what this graph looks like, and that's what I was fixing to talk about. So what the book wants you to do then is to pick several x's. Like I could plug in negative 2 and get a point, plug in negative 1 and get a point, plug in 1 or 2 or 3, get a point, and get enough points to get, again, I'm expecting some boomerangs here. So what I'm expecting is you're going to get something around here and it's going to do this. Then I would pick values over here on this side of the vertical asymptote, maybe negative 4, negative 5, negative 6, some numbers over here, plug them in, get some points, and plot it. I'm going to let you cheat a little bit, okay? That's what we should do, but again, what they're most interested in is you being able to find this kind of stuff, the transformations, the vertical asymptotes, the horizontal asymptotes, the X-intercepts, and the Y-intercepts. After that, we're going to cheat a little bit, and we're going to type it in the graphing calculator, and we're just going to sketch it out. So you can see it gets real close to this asymptote, but doesn't touch it. Comes real close to the horizontal and doesn't touch it. And on this side, it's approaching both asymptotes also. So there's my graph. Now, we also have to use limits to describe the corresponding behavior. And what they mean by that is what happens, finding the limit, as x approaches infinity, and what happens as x approaches negative infinity. Well, if I trace my graph, as x gets bigger and bigger and bigger, as I head towards infinity, if I trace the graph towards infinity, it's coming down and it's getting closer and closer and closer to this horizontal asymptote. So the function is approaching 0 as I go bigger and bigger and bigger. On this way, if I go farther and farther left and I trace the function to the left, again, that boomerang is getting really, really close to this horizontal blue line, which is at y equals 0. So the function is going to 0. Okay? Alright, let's try another one. So we've got a mess here because the top has a variable in it. Okay? Because remember, I'm trying to make it look like this, or figure out what they did. When the top has a variable in it, you have to do long division. So I'm going to do x minus 2 into 3x minus 7. If I go to the alley, 3x divided by x is 3. So I put 3 up, multiply down. 3 times x is 3x. 3 times negative 2 is negative 6. Draw the line, change the signs, cancel the x, and I have negative 1. So 3x minus 7 over x minus 2 equals 3 minus 1 over x minus 2. Okay? So now, if you see my function, h of x, if I write it properly, I have negative 1 times 1 over x minus 2 plus 3. Put this on the end, put this down, and put 1 up top. Alright, and there's my function. So now I can see that that negative 2 is going to shift it 2 units to the right. The positive 3 on the end is going to shift it up 3. The negative is going to reflect over x, and the 1 is going to be a vertical stretch, but multiplying by 1 isn't going to change anything. So there's my transformation. Okay? And I'm going to need some more room, so I'm going to rewrite this up here. This equals 3, well, right that way. Negative 1 times 1 over x minus 2 plus 3. Okay, so now I'm going to erase this so that I can have some room to plug into the rest of my stuff. Okay, so the next thing it wants are the horizontal and vertical asymptotes. To get my vertical asymptote, you say, Mr. Denominator, you can never equal 0, which means x can never equal 2. So there's 2 on the x. Vertical asymptotes run up and down. Okay, to get my horizontal asymptote, we look at degrees. The degree on top is 1. The degree on bottom is 1. When they're equal, your horizontal asymptote is the top leading coefficient divided by the bottom leading coefficient. So y equals 3 is my horizontal asymptote. So there's 3 on the y, and I make a horizontal line through it. So now what I'm expecting is my boomerangs to either be here and here, or here and here. Okay? And again, that's why we're going to find the X-intercepts and the Y-intercepts to get a clue of where this thing boomerangs at. So if I get my X-intercepts, you set your numerator equal to 0. So if I set 3x minus 7 equal to 0 and solve, plus 7, 3x equals 7, divide by 3, x equals 7/3, which is approximately 2.3 repeating. Okay, so it's going to cross the x-axis at about right there. Okay, which tells me I'm boomeranging in these 2 quadrants. And I can tell that because that's negative. Anyway, just a little side note there. Now I'm going to find my Y-intercept. To get my Y-intercept, we find h of 0, which is going to be 3 times 0 minus 7 over 0 minus 2. That's going to be negative 7 over negative 2, which is positive 3.5. So it's going to cross the y-axis at 3.5. Okay? So now I can probably guess, I'll check on the calculator, but what I'm guessing is this thing does this. It goes asymptotic between the asymptotes, and it passes through those 2 points. And then I'm going to get a little clue from my graph, and sure enough, there it is. Okay? Oh, limits. Alright, so the limit as x approaches infinity as I approach infinity, so as I trace the graph going to the right, this thing is getting closer and closer and closer to that green line, which was y equals 3. So my function is getting close to 3. The limit as x approaches negative infinity, if I trace this side, again, it's getting closer and closer to that green line, so the function is getting closer and closer to 3. Okay? Alright, so you try this one. Hit pause, come back when you're ready. And hopefully you got 4. Okay, I can rewrite this function as -2 times 1 over x plus 5. So that tells me that the positive 5 is going to move this thing 5 left. The negative is going to reflect over x, and the 2 is going to be a vertical stretch. Okay, so left 5, reflect over x, stretch by 2. Alright, and there's the graph to prove it. You try this one, hit pause, come back when you're ready, and hopefully you got 3. Okay, this one we can't tell, we're going to have to do long division, so if I do x plus 4 into 5x minus 1, 5x divided by x is 5, so 5 goes up, times x is 5x, times 4 is 20. Draw the line and change the signs. The x's cancel and I get -21. So 5x minus 1 over x plus 4 is equal to 5 minus 21 over x plus 4, which I can then write as 5 minus 21 times 1 over x plus 4, which I can rewrite as -21 times 1 over x plus 4 plus 5 on the end. And then it's easy to read. Okay, you got your positive 4 on the bottom, which is going to move it left 4. You got your positive 5 on the outside, which is going to move it up 5. You've got the negative on the outside, which is going to reflect over x. And you've got the 21, which is going to be a vertical stretch. So it's going to go left 4, reflect over x, stretch by 21, and 5 up. Okay? Alright, and the graph proves it. So, how do you recognize a rational function? If it's a fraction with a variable in denominator. And how do you graph the vertical asymptotes, holes, and horizontal asymptotes for a rational function? You find your vertical asymptotes by setting your denominator not equal to 0. You find your horizontal asymptotes by looking at your degree rules. Okay, and I would write the degree rules. If the top degree is smaller than the bottom degree, then y equals 0. If top degree equals bottom degree, then y equals top leading coefficient divided by bottom leading coefficient. And if top degree is bigger than bottom degree, then there's no ha, but there will be a slant asymptote. Okay, so it says evaluate the limit based on the graph of f shown. They're going to ask you to take limits as you go to negative infinity, to positive infinity, and then to your vertical asymptotes. Okay? And you got to pay attention which way to approach it. This says as x goes to negative infinity. So if I trace the function going left, it's getting closer and closer to this dotted line, which is at y equals 3. So the function is approaching 3. Same as I go to positive infinity. If I trace this going to positive infinity, the boomerang is getting really, really close to this line. So the function is approaching 3. Okay, now to do my limits, this says the limit as x approaches 2 from the right. So I'm approaching 2 on the x-axis, but I'm approaching it from the right. So I've got to trace this one. If I approach 2 from the right, as I get closer and closer to 2, this function is going down and down and down. So the function is heading towards negative infinity. As I get close to this dotted line, the green one I'm drawing, the function's going down to negative infinity. On this side, as I approach 2 from the left, I have to draw this side of it. I'm approaching the green line from the left. I'm tracing the function, which is now heading up and up and up and up and up, which means it's heading towards infinity. Alright, so you try one, hit pause, come back when you're ready. And hopefully you got negative infinity. This says find the limit as x approaches 5 from the right. 1, 2, 3, 4, there's 5. You can see there's a vertical asymptote there. I mean, they don't draw it in for you. But as I approach this from the right, so I'm tracing the graph this way, and where is it heading? It's heading down, so that's towards negative infinity. Okay? Try this one. Hit pause, come back when you're ready. And hopefully you got 0. This says approach as x approaches infinity from the left. So I'm heading towards negative infinity. So I'm tracing this part of the graph, and it's getting closer and closer to this imaginary horizontal asymptote. So it's getting closer and closer to there, which is, that line is y equals 0, so the function is getting close to 0. Okay? So how do you predict the end behavior of a rational function? You basically trace it in the direction the limit says and find the number. Alright, so it says more practice here. We're going to find the horizontal vertical asymptotes. We're going to use limits to describe the behavior, X-intercepts, Y-intercepts, and graph the function. Alright, so first of all, we have to figure out the vertical and horizontal asymptotes. So, I'm going to cover here. I don't know how you want to start this. To do vertical asymptotes, I say Mr. Denominator, you can never equal 0. So minus 3, I have x squared cannot equal negative 3, square root, x cannot equal plus or minus I square roots of 3. Since the only vertical asymptotes there are imaginary, there are no vertical asymptotes. Okay? So next I'm going to find my horizontal asymptotes. My horizontal asymptotes you get by degrees. My top degree is 2. My bottom degree is 2. Those are equal, so my y-intercept is at the top leading coefficient divided by the bottom leading coefficient. So I have a horizontal asymptote at y equals 2. There's 2 on the y-axis. Horizontal means straight across. Okay? So there's my horizontal asymptote. Then we're going to get some x-intercepts and some y-intercepts. To get my x-intercepts, you say Mr. Numerator, set it to 0. So add 1, 2x squared equals 1. Divide by 2, x squared equals 1/2. Square root, x equals plus or minus the square root of 0.5 is 0.71 if I round. So this thing's going to cross the x-axis at positive 0.71 and at negative 0.71. Okay, so now I'm going to find my y-intercept. Oops, sorry, I showed the picture there too. To get my y-intercept, you find f of 0, which would be 2 times 0 squared minus 1 over 0 squared plus 3. So that's going to be negative 1/3, which is negative 0.3 repeating. So it's going to touch about right there. Okay. Now, to figure out what this graph does, again, I'm old and I'm expecting it to do this, okay, because there's no vertical asymptotes. But again, what you would do if you had to do this by hand is you would pick several x's, maybe 2, plug it in, 3, plug it in, I don't know, 5, plug it in, 7, plug it in. Maybe over here, try negative 2, negative 5, negative 7. you could get the points and plot them and then connect them. We're cheating a little bit, and we're going to go to the graphing calculator, and sure enough, this thing approaches the horizontal asymptote, connects those dots, and goes like that. Okay, and we have to use limits. So the limit as x approaches positive infinity, if I trace it going right, this thing's getting closer and closer to that green line, so the function is getting closer and closer to 2. The limit as x approaches negative infinity, again, if I trace this side of it, it's getting close to that green line, which means the function values are getting closer and closer to 2. Okay? Alright, let's try another one. So let's look at vertical asymptotes. Mr. Denominator can never equal 0. I can factor this. I can factor out an x, which would leave x minus 1 cannot be 0, which means x cannot be 0 and x cannot be 1. So at 0 and at 1, I'm going to have vertical asymptotes. Okay? There's my vertical asymptotes. To get my horizontal asymptotes, I look at the degrees. My top degree is 1. My bottom degree is 2. The top degree is smaller than my bottom degree, which means my horizontal asymptotes at y equals 0, which is right there. Okay, so now I'm going to get some X-Intercepts. To get my X-Intercepts, I set my numerator equal to 0 and solve it. Minus 1, minus 1. 2x equals negative 1. Divide by 2, divide by 2. X equals negative 1/2. So it's going to cross the x-axis at negative 1/2. Okay, to get my Y-Intercepts, I find f of 0, which is going to be 2 times 0 plus 1 over 0 squared minus 0, which is going to be 1 over 0, which is undefined. So it's not going to touch the y-axis. There's not going to be a y-intercept. Okay, so it's not going to cross the y-axis. Alright, so after that we should pick some points and figure out what's going to happen. We'd have to pick some over here. Maybe negative 1, negative 4, I don't know. We'd have to pick something in between, like maybe 1/2 and 2/3 and, I don't know, 3/5. And we'd have to pick some stuff over here to figure out what's happening in each section of this graph. We're going to cheat a little bit and look at the picture. Okay? So it looks like this thing comes down, it's approaching here, comes down, touches here and approaches this. You can actually cross over horizontal asymptotes. You can't touch verticals, but you can actually cross over horizontals. And then on this side, it does this. Okay? Alrighty. Oh, limits. So the limit, as x approaches infinity, if I trace this going right towards infinity, it's getting closer and closer to the green line. So the function is approaching 0. And as I go to the left, the limit, as x approaches negative infinity, if I trace this to the left, it goes through it, but then it comes back up and it's getting closer and closer to the green line again. So the function is approaching 0. Okay? Alright, let's try another one. Alright, so first of all, I'm going to find my vertical asymptotes, which says, Mr. Denominator, you can never equal 0. Add 9, x squared equals 9, square root, x equals plus or minus 3. So at positive 3, I'm going to have a vertical asymptote, and at negative 3, I'm going to have a vertical asymptote. Okay, next we're going to find our horizontal asymptotes. We look at degree rules. My top degree is 3. My bottom degree is 2. Since the top degree is bigger than the bottom degree, there's no hop. But there will be a slant asymptote. Okay, or they also call it an oblique asymptote. And all you do is you do the division. So I'm going to have x squared minus 9 divided into x cubed. X cubed divided by x squared is x, times x squared is x cubed, times negative 9 is negative 9x. Draw the line, change the signs, third degrees cancel, and I'm left with 9x. So I have x cubed over x squared minus 9 equals x plus 9x over x squared minus 9. Agreed? This part, I don't care about the remainder part, but this part right here, if I wrote that as an equation, I'd have y equals x. Sorry. I'd have y equals x. That is the mother function, the identity, which passes through the origin, starts at 0, 0, slope of 1. Okay? Whatever this thing does, the end behavior, not the middle, but the end behavior is going to follow that slant asymptote. Okay? So, to get our hint of what's happening, we're going to find our x-intercepts and our y-intercepts. To get my x-intercept, I set my numerator equal to 0 and solve it. Take the cube root, x equals 0. So it's going to cross at 0. My y-intercept is when I find f of 0, which is going to be 0 cubed over 0 squared minus 9, which is 0 over negative 9, which is 0. Anytime it crosses x at 0, it's got to cross y at 0. It's got to go through the origin. Okay, so again, at this point now, we would pick several points. We'd have to pick a lot of points over here to figure out what's happening over here. Is there a boomerang here? Is there one here? We'd have to pick a lot of points over here to figure out if the boomerang is in between or here. And then we'd have to figure out a bunch of points in between to figure out what's happening in the middle. Okay, and again, I'm being nice and letting you cheat. That's what we should do by hand. At this point, I type it in the graphing calculator and I can see that this thing does this in the boomerangs. Try not to make them all crooked. And in the middle, it has this S-curve. Again, you can't cross the vertical asymptotes, but you can pass through the horizontal asymptote or the oblique asymptote, the slant asymptote. Okay? Alright. Let's go again. So my vertical asymptotes are going to be when Mr. Denominator can never equal 0. I'm going to factor that. It should be an easy factor because A is 1. Factors of 3 that make 2 are 1 and 3. Since C is negative, only the bully gets the middle. So 3 is negative, 1 is positive. So x can never be negative 1 and x can never be 3. So at negative 1, I'm going to have a vertical asymptote. And at positive 3, I'm going to have a vertical asymptote. Okay, to get my horizontal asymptotes, I look at my degree rules. My top degree is 1. My bottom degree is 2. So since my top degree is smaller than my bottom degree, my horizontal asymptotes at y equals 0. Okay, we need some x-intercepts and some y-intercepts. To get my x-intercepts, I set my numerator equal to 0 and solve it. And I get x equals 2. So it's going to cross the x-axis at 2. To get my y-intercept, I find f of 0, which is going to be 0 minus 2 over 0 squared minus 2 times 0 minus 3, which is going to be negative 2 divided by negative 3, which is 0.666 repeating. So it's going to cross the y-axis at 0.66666. Okay? After that, we should pick some points and figure out what's happening, but we're going to cheat a little bit and look at the graph. I suspected boomerangs here, an S in the middle, and boomerangs here. Okay, my limit as x approaches infinity, my function, as I trace it to the right, it's getting closer and closer to the blue line, so the function is approaching 0. And the limit as x approaches negative infinity, If I trace it this way, again, the function's getting closer and closer to the blue line, so the function is approaching 0. Now, we could also describe the behavior in the middle, and we could describe the limit as x approaches -1 from the left and from the right, and we could do +3 from the left, from the right, but if they want that, they'll specifically ask you. Alright, so another one. To find my vertical asymptotes, I set Mr. Denominator can never equal 0. I'm going to factor, that's going to be x squared minus 1. This, if I set them to 0 now, so x can never equal 0. X squared minus 1 can never equal 0. Plus 1, x squared can never equal 1. Square root. X can never equal plus or minus 1. So we have, wow, 3 vertical asymptotes. We're going to have one at -1. They're really close together. One at 0 and one at +1. Okay, there's my verticals. My horizontal asymptote, I look at degrees. My top degree is 0. My bottom degree is 3. My top degree is smaller than the bottom degree, so my horizontal asymptote's at y equals 0. Okay, I need some X-intercepts and some Y-intercepts. To get my X-intercepts, I set my numerator to 0, but there's no x in it, so there's no X-intercepts. This thing won't cross the x-axis. To get my Y-intercept, I find f of 0, which is going to be 2 over 0 cubed minus 0, which is 2 over 0, which is undefined, which means there's no Y-intercepts. So to get my picture, again, I should pick a whole bunch of points. Some over here, some in the middle, some. That can get very tedious, so we're going to cheat, and we're going to look at the graph. And I've got boomerangs here and here. You're starting to notice how they always boomerang? Just this weird stuff in the middle when you get these degrees going on. You got a parabola up here, and you got a parabola down here. Okay? Alright, so you do this one. They want the x and y intercepts, and then graph the function. Hit pause, come back when you're ready. And hopefully you got 2. Alright, if you did not, to find my x-intercepts, I set numerator equal to 0. Plus 5, I get 3x equals 5. Divide by 3, I get x equals 5/3. Okay, an x-intercept is when y is 0. So it's an ordered pair, that's 5/3, 0. To get my y-intercept, I find f of 0, which is 3 times 0 minus 5 over 0 minus 2, which is -5 over -2, which is positive 5/2. So that ordered pair would be 0, 5/2. So there's my correct intercepts. And then again, I mean, they didn't really ask you to do all the, I mean, they asked you to graph it, but you can type it in the calculator, obviously. But if I was doing the work, I'm going to have a vertical asymptote when Mr. Denominator can never equal 0, so x can never equal 2, which puts me a vertical asymptote at 2. My horizontal asymptote is going to be degree rules. My top degree is 1, my bottom degree is 1. They're equal, so my horizontal asymptote is the top leading coefficient divided by the bottom leading coefficient, which is y equals 3. So there's the right asymptotes, and then they boomerang in the quadrant. Yeah? Alright. Try this one. Come back when you're ready. And hopefully you got 4. Alright. If I find my x-intercepts, Mr. Numerator equals 0, I can factor, should be an easy factor, a is 1. Factors of 6 that make 1 are 2 and 3. Since c is negative, only the bully gets the negative and 2 doesn't, so x equals -2 and x equals 3. Those y-intercepts, x-intercepts, you get when y is 0, so those are my x-intercepts. Okay, my y-intercept, I'm going to find f of 0, which would be 0 squared minus 0 minus 6 over 0 plus 4. That's negative 6 divided by 4, which reduces down to negative 3 halves. So this thing crosses at negative 2, at positive 3. Cross there if you ask me. Alright, and 0, negative 3 halves would be about right there. Negative 1.5. I don't think they drew the graph very well. Oh, they're counting by 2s. That's why. So there's 3. My bad. Okay, so there's the X and the Y-intercepts, and again, you would type it in to get your boomerangs happening there. The vertical asymptote is at X equals negative 4. Because Mr. Denominator can never equal 0, so X can never equal negative 4. Your horizontal asymptotes, the top degree is 2, the bottom degree is 1. Since top degree is bigger than the bottom degree, there's no ha, but there is a slant, and if I divide, x squared minus 6, x plus 4 goes in there x times, that's x squared plus 4x, draw the line, change the signs, that's negative 5x minus 6. Negative 5x divided by x is negative 5. That's negative 5x minus 20. Change the signs and I get a remainder of 14. Which I don't care about the remainder. Whatever's on top is your slant asymptote. If I graphed that, notice I would start at negative 5. And here they're counting by 2, 4, 6. Here they're counting by 2. So 2, 4, there's 5. And then I would go up 1, right 1, and there's my slant asymptote. Y equals x minus 5. Alright, so how do you graph the x and y intercepts of a rational function? You get your x-intercepts by setting numerator equal to 0 and solve. You get your y-intercept by finding f of 0 and plotting. Alright, so we are at homework, so we are done. Happy homeworking, and I will see you next